Hey guys, this is Mrs. Finnemeyer. We're going to be looking at Chapter 1, Lesson 3, which is on multiplying and dividing monomials. And in this particular video, we are going to focus on dividing monomials. So the rule that we are looking at today is quotient of power rules. So remember the word quotient we typically put with division. So here we have 3 to the 7th power divided by 3 to the 3rd power. And it's just written as a fraction here. So in the numerator, 3 to the 7th power would just be 3 times 3 times 3 times 3 times 3 times 3 times 3, 7 times. And in the denominator, it would just be 3 factors of 3, just like that. Now we know with division, anytime we have a number divided by itself, that equals 1. So in these fractions, we typically cancel those out. We cross them out because they equal 1. So for this set of 3's, we can cancel those out. For this set of 3's, we can cancel those out. For this set of 3's, we can cancel those out. Now notice there's no more 3's in the denominator, so there's nothing else that we can cancel out. And what are we left with? We're left with 4 factors of 3 in the numerator. So that's just 3 to the 4th power. And again, we'll come back to that example. Let's take a look at another one. Here we have a to the 5th over a squared. So this time my base is a variable. A to the 5th would just be 5 factors of a in the numerator, and a squared would just be 2 factors of a in the denominator, a times a. Again, we can go ahead and cancel out any sets of like bases in the numerator and denominator. So a and a will cancel. This a and this a will cancel. And what are we left with? We are left with 3 factors of a multiplied together. That is the same thing as a to the 3rd power. So now if we look at those two examples together and take a look at their exponents in particular. In the first example, the base of 3 doesn't change, but notice we went from a 7 and a 3, and that became 4. So what do you do with 7 and 3 to get 4? Well, you subtract. So here we're keeping the base the same, 3, and we're taking 7 minus 3. Notice that the exponent in the numerator is written first, and then you're subtracting the one in the denominator. And if we take a look at the second example, a to the 5th over a squared, again, the a's stay the same, but our exponents change. What do you do with 5 and 2 to get 3? Well, again, you subtract. So here we're taking a to the 5 minus 2. Again, the exponent in the numerator is written first, minus the exponent in the denominator. So our quotient of powers rule, this is on page 25 of your book. Here, the focus is when you are dividing powers, only when you are dividing with the same base, they have to have the same base, then you are going to subtract the exponents. Okay, the key is to subtract the exponents. I often say the trick, think of that fraction line almost as if it's a subtraction sign for the exponents. So for the numbers, they're showing 3 to the 7th over 3 to the 3rd becomes 3 to the 7 minus 3, or 3 to the 4th. And then the algebraic expression, that just means that it's all variables. A to the m over a to the n, you keep that base of a the same and you subtract the exponents. Now they do note that a cannot equal 0. Just keep in mind you can never have 0 in the denominator of a fraction. Now if we stop and reflect for a minute, explain why the quotient of powers rule cannot be used to simplify the expression x to the 5th over x to the 3rd. So take a second to think about that. Well, it cannot be used because the quotient of powers rule only applies when the bases are the same. Here in the numerator, the base is x, and in the denominator, the base is y. So that rule does not apply to this problem. That is actually already simplified. All right, let's take a look at 2 more complex problems. Here in example 1, we have 8y to the 6th over 2y to the 4th. So if we write those out, that's really just 8 times and then 6 y's on the top. And in the denominator, we have 2 times and then 4 y's in the denominator. We're going to take a look at these coefficients, 8 and 2. Those we are going to do the usual 8 divided by 2, which will give me 4. And then for the variables, we can go ahead and cancel out any pairs in both the numerator and denominator. So I've got a y in the numerator and denominator, another y, another set of y's that I can cancel, another set of y's that I can cancel. And now there's no more y's to cancel in the denominator, so I need to stop there. Well, we already said that 8 divided by 2 is 4, and then we're left with 2 y's in the numerator, so that is y squared left over. Now if we look at the second example, we have 9x times x times x times x times x times y times y times y in the numerator. As you can see, it's getting a little bit messier. And in the denominator, we have 2 times x times y times y. And now if we go through, we have 9 in the numerator divided by 2 in the denominator. But 9 divided by 2 does not simplify to a whole number, so we're actually just going to leave that. That does not simplify at all. And then if we go through and look for pairs, we've got a y in the numerator, y in the denominator to cancel out, another y in the numerator, another y in the denominator. There's no more y's to cancel in the denominator, but I do have x's in both the numerator and denominator. Now, that's all that I can cancel for that problem. So what am I left with? Well, in the numerator, I'm left with a 9, and 4 x's, and 1 y. And in the denominator, I'm just left with a 2. So if you go back to the original problem and look, we just did 9 divided by 2, which didn't simplify at all. And then we took our exponents for the like bases, and we subtracted those. 5 minus 1 was 4, and that stays with the x. And then 3 minus 2 is 1, or just y. Now, what I want you to try is on page 25, I want you to try these 6 got it problems. If you don't have your book, go ahead and just write these down on a sheet of paper and give them a try. Alright, let's take a look at what you've got here. So in the first one, 5 to the 7th over 5 to the 4th, well, we're just going, the like base is 5, we're going to subtract the exponents, and that gives us 5 to the 3rd power. In letter E, I have a like base of x, and I'm taking the exponents 10 and subtracting 3, and that will give me x to the 7th power. In letter F, we're taking 12 divided by 2, which is 6, and w to the 5th minus w to the 1st. Remember, in the denominator, that w has an exponent of 1. So that gives me 6w to the 4th power. Now in letter G, we've got a bunch of different bases. We have a 3, a 5, and a 7 in the numerator and the denominator. So we're just going to go through and subtract the exponents. 3 to the 4 minus 2, 5 to the 2 minus 1, 7 to the 5 minus 3. And that'll leave me with 3 to the 2nd times 5 to the 1st times 7 to the 2nd. Now sometimes you'll see that they leave the answer that way. Other times they'll actually want you to go ahead and type that into the calculator, in which case you would get 2,205. Now the same thing with letter H. We're just going to subtract the exponents of the like bases. So 5 to the 6 minus 4, 7 to the 4 minus 2, and 8 to the 3 minus 2. Notice we're still multiplying each of those together. And so here we would get 5 to the 2nd times 7 to the 2nd times 8. And again, you may see the answer left that way, or they might ask you to simplify it even further, and you can type that into the calculator and get 9,800. Now I seems a little bit tricky because of those parentheses, but again that's a like base of -2, so we just leave it in parentheses, -2 to the 5 minus 2, 3 to the 4 minus 1, and 5 to the 7 minus 4. And that would leave you with -2 to the third times 3 to the third times 5 to the third. Now again, they may ask you to take it a step further, in which case that would be -27,000, or you may see it left at this middle step here. Alright, so just to summarize all of that, the quotient of powers rule says that when you are dividing monomials, so again, this is when we are dividing, it looks like fractions most of the time, with like bases, you are going to subtract the exponents. And again, it only works when you're dividing and you have like bases.